Okay, I'm recording this after the fact, so basically, I originally recorded the video only doing 2 Volta sessions. So there were 2 separate sessions connecting to the same machine rather than uh, having it connect to the JSON server and also the Volta server and then having them connect to each other. My original showed that it works, but in case it matters, I'm going to show that it works also with JSON and Volta connecting through to each other. So I will do that now. And then this will have probably a very abrupt jump to the previous video I recorded, but just to start, I'm going to show it working on the JSON and Volta. So I have config CDIP 130.191.166.4. So I start the server with port 5000, and now I start the client from JSON to that IP address with port 5000. And now if I type Justin Lee, this is my sentence. You see that it works, and these are 2 separate machines with the JSON Volta. So that is all that I needed to show at the start of this video, and I'm going to go through this again with it Volta, but yep, I just wanted to include it to show it works. Okay, this is my project 2 for COMPE560. So first I'm going to start my emulators, 2 emulators, one for the server, one for the client, connecting to the Volta server. I have to get my password real quick. Okay. So that one's logged in. I'll make another one. That one's also logged in. Now I have 2. Okay, now I'm going to build the code for the client. As well as for the server. And for the server, I have to specify the C standard as C99. Alright. So I'll run the server with the port 5000. And then on the other one, I'll run the client connecting to the loopback address 127.0.0.1 with port 5000. Whoops. // client.out. And for the Justin Lee, this is my test sentence. And we see it in reverse. Justin Lee. This is my test sentence. So on the server side, it received the sentence message, and then it reversed it and sent it back, and then this is the reversed message being printed after it receives it from the server. And now I'll also look at the code. So there's the client.c. I'll scroll through it, and you'll see that it matches the code that I submitted, as well as the server C. Also matches. Okay. Now we can start looking at the code. And I'll just bring up the code on Visual Studio Code because it's easier to read. So we'll look at the client's code first because I think it's simpler. Initially, it's just checking argc to see if the number of arguments is correct. If it's not, it'll print the correct usage, which would be executing it, and then the first argument will be the address to connect to. We used 127.0.0.1 for the address, and then the port we used 5000 since we set the server to listen on. And then this right here, we're using scanf to read the port. So it takes argv2, which corresponds to the port that we give as an argument to the program, and scanf is sort of like scanf but for a string. So we take the string for that argv and stick it into the port integer variable. This next one's the first sort of socket part. We call the socket function to create a new socket with AF inet sock stream, and these arguments pretty much give it a TCP socket, and the return value of this is an integer, which is the handle for the socket, and that's what we set the client socket to. If there's an error, it will exit out. Now this next line, so this sets up the address that it's going to connect to. AF inet, the same as it was before when we made the socket. And then for the address, we use the inet_adder function, which converts a string IP address, which we got from the argument that was given by the user when we typed 127.0.0.1 for the argv. And it will convert it basically into like a set of bytes that the computer can understand for that. And then also for the port, we use htons, this function that will convert the host byte order, or it'll convert the port from host byte order to network byte order. And then once that's all done to where it has the address that it's going to connect to, it will call the connect function, which actually takes the socket that we made earlier and creates the connection to the server. So now that the connection exists, it's ready to receive input from the user, which is right here when we typed my name and then a sentence. We use the fgetS function, which will receive input from the standard input and stores it inside this buffer. The fgetS function, it will put a \n at the end of this string rather than a null terminating character. So I manually set that character to be a \0 null terminator character so that it makes things easier later on when we're printing it. And then this strcspn function basically counts, it says it right there, finds the number of characters that it passes until it reaches \n. So whatever that number is would be the address or the index of the \n, so that we could replace it with the null terminator. Then this line of code sends the string that we just got from the user to the server through the client socket. And then for the length of the data that we're going to send, we use strlength buffer +1, because the strlength won't include the null terminator character, and I wanted it to include that, so I added one. Then after that, that's when control is pretty much taken over by the server. So return here after. We're going to jump over to the server and talk about that and then get back to the client. So for the server, very similarly, we do argc, checking if the number of arguments given is correct, and if it's not, list how they're supposed to give it. And as we used it before, server.out 5000 using that port, it's the same thing here. So that 5000 that we gave is in one of these strings in the argv pointer, and we do the same scanf to put that port into an integer. And then also identically, we make a server socket using the socket function with AF inet sockstream for TCP. And if there's any errors, we print that there was an error and exit, as we do everywhere else that could happen. And this is the first major difference for the address. Rather than having an actual specific address like the client had for connecting to a specific server, this address is in adder_any, which pretty much makes the address 0.0.0.0 to match any incoming address. So any client that wants to connect will be allowed to connect. And then for the port, we do the same host byte order converting to network byte order. And then rather than the connect function earlier that we used in the client, we're using bind, which takes this like address mask pretty much and binds it to the socket that we made. So the operating system knows that any connections that are coming in that match those addresses should go to this socket. Now this function listen makes it actually start listening for those connections, and then right here on line 39, that's getting a new socket for the client for the next connection that comes in. So the accept function will just take this, where is it? The connect. When it connects, this is where that socket gets created on the server side. Now we create a buffer and then receive. So that's exactly where we are here. So it sent something and now the server received it. So the server previously would have been blocking on this function just after having been connected to while the user was typing their input, and then after it sends, it will receive. So as soon as it receives the data, it will print it, and then this code reverses the string. So it just makes a new string, allocating the number of characters that it will need for the string, and then it just for loops in reverse from the character just before the null terminator all the way to 0, replacing the characters in reverse order, and then adding a null terminator at the very end for the reverse string to be proper. And then after that reverse string is constructed, it will send it back to the client in a similar way to how it did that. The client did that. After that happens, it'll close its sockets and be done. And then if we go back to the client will have been blocking on the receive as all of this was happening, as it was printing and reversing. This would have been like very fast, but it would have been blocking for some amount of time. Then it'll receive the reversed string that this will have sent, and it will print it and then close the socket, clean up, and then return. So that is the whole code path explained. And that's everything for up to part 6. Now, what are sockets and on what layer do they operate? So the sockets are operating on the transport layer, because it's like the port and IP address, basically mapping these applications to the lower level transport layer. So yeah, sockets are on the transport layer. Sockets are pretty much like network connections. It's a way that applications can use the TCP layer and connect to other devices. So the difference between TCP and UDP. TCP has a whole handshake protocol, and it's like a connection that's like solid and long lasting. So a TCP connection can be made, and there can be many sends and receives to and from the server and client, and everything happens in order. Whereas with UDP, things can be received out of order. It's sort of shoot and forget. So the client might send many things to the server, and depending on what route any of them take, all the packets take, you might receive data out of order. UDP is less overhead, TCP is higher overhead. This assignment I mentioned earlier, we're using SockStream AFINet, that's TCP. Then for YouTube, it depends, I guess, on what you mean by that. For the website, youtube.com, when I connect to that, that's like HTTP running like TCP. But playing a video, at least with how they have it now, if you're on HTTP3, it will be using Quick, which uses UDP under the hood. But for older versions of HTTP, I believe it was TCP. But yeah. Now, what will happen if I use an out-of-range port in my code? For my code, you will not run into an error. And the reason is because the scanf is gonna truncate your input pretty much. So the it won't. Yeah. So I can give an example of that. If I run the server out 666666, so it's listening on port out of range. If I convert to hexadecimal and then convert the truncated like small bits to decimal, 11306. So if I connect from the client with that port 11306, just in Lee test, you see it still functions properly even though we put different ports. That's because of the port being truncated. And so not technically an error, but maybe semantically an error. But the program won't crash. And now for the number of sockets that a client and server can have. So back here is for the client. Each socket has a address and a port. Addresses are 32-bit. Ports are 16-bit. So that would give you 2 to the power of 48 possible sockets that you could have simultaneously without logically running into error. That could never happen because a computer couldn't store that. The operating system probably would have like a hard limit on, arbitrary limit on what that maximum amount of sockets could be. But I guess theoretically it would be 2 to the 48. And then on the server side, if I have an application running on each port, that'd be 2 to the 16 ports. And then each of those ports could accept clients from any address, that would be the same 2 to the 48. Different sockets running on the server side as well. So, yep, that's my project. Thank you.